Hello students, in this particular section we are going to discuss regarding module number 2. So in previous lecture we discussed regarding module 1, what are the expected questions in VTU examinations. In this particular sections we are going to discuss with respect to module number 2, that is analysis of force system. In the analysis of force system, generally the force systems, that is concurrent and non-concurrent. In this particular module 2, we are going to discuss only concurrent force system. So in force system we are having concurrent and non-concurrent. What is mean by concurrent? Concurrent mean by all forces meet at a single point. All forces meet at a single point is called concurrent. What is meant by non-concurrent? Forces are not meet at a single point. It's a diverse in all directions. So if it is a single plane, then we call it as coplanar concurrent. If it is a single plane, we call it as coplanar. If it is not more than one plane, is called non-coplanar. So here we are having coplanar concurrent. In a single plane, all forces meet at a single point is known as coplanar concurrent. In the different planes, all forces meet at a single point is known as coplanar, non-coplanar concurrent. Similarly, in a single plane, all forces never meet at a single point is called coplanar non-concurrent. Similarly, more than one plane, all forces never meet at a single point is called non-coplanar non-concurrent. But in module number 2, we are having coplanar concurrent and non-coplanar concurrent forces. Analysis of coplanar concurrent and non-coplanar concurrent forces. So now, what are the expected questions in VTU examination? Here you are having 3 theorems. That is very, very important. One is state and explain. State and explain. Parallelogram, state and prove. State and prove. Parallelogram law of forces. Law of forces. State and prove Varignon's theorem of moments. Varignon's theorem of moments. State and prove Varignon's theorem of moments. State and prove Lamy's theorem. State and prove Lamy's theorem. State and prove Lamy's theorem. See, these 3 theorems are very, very important. One is parallelogram law of forces. The next one is Varignon's theorem of moments. The next one is Lamy's theorem. Within these 3 derivations, that is theorems, you may expect one question in VTU exam. Definitely they will ask any one derivation for minimum 6 marks. So please take care regarding these questions, and also you are having few theory questions in this particular chapter. Those theory questions are explain idealization in engineering mechanics, explain idealization in engineering mechanics, and explain principle of superposition. Explain principle of superposition, transmissibility, and transmissibility, force and its characteristics, couple and its characteristics, and also free body diagram. And resultant and equilibrium. Right. We discuss one by one. Here, parallelogram law of forces, you have to prove the resultant as well as its inclination. Here, this parallelogram law is applicable for only two concurrent forces. P and Q are the two forces meet at a single point, then the resultant is given by R equals square root of P square plus Q square plus 2PQ cos alpha. That is the resultant equation. And also its theta, resultant inclination is given by theta equal tan inverse of sin theta divided by P plus Q cos theta. That is very, very important in parallelogram law. Here, Varigner's theorem of moments. Here, in addition to resultant, you have to determine the positions. Resultant can be determined using the equation R equals square root of sigma fx square plus sigma fy square. Theta is also the same, theta equal tan inverse of magnitude of sigma fy by sigma fx. But in addition, you are determining position, that is g value, x intercept and y intercept. In Lami's theorem is applicable for three concurrent forces meet at a single point. So on that case, you are taking P divided by sin alpha equal Q divided by sin beta equal R divided by sin gamma. So there is a proportionality. So you have to equate two things and determine a known force in Lami's theorem. Explain idealization in engineering mechanics. Idealizations means to ascertain a civil engineering problem, it is very toughest task to analyze in a single step. That's why we are doing discretization of structures. For the discretization, we are assuming some certain things like particle, rigid body, concentrated force, and also continuum. So these four are idealizations in mechanics. So the thing individually you have to explain. And this is very, very important thing, that is principle of superpose, and also transmissibility, and force and its characteristics, couple and its characteristics, free body diagram, and resultant and equilibrium. Resultant means resultant is the sum of all the forces acting on a body, while equilibrium is, that is the extra force required to bring the body in equilibrium. That is very, very important. In equilibrium, you are getting the equation sigma fx equals 0, sigma fy equals 0, and sigma m equals 0 for non-concurrent force system. Sigma fx equals 0 and sigma fy equals 0 for non-concurrent or concurrent force system. This is very, very important. In module number 2, these are the expected theory questions. In the final examination. Now we will discuss what are the numericals associated in module number 2. These are theory questions, and also we are having two parts in this particular thing. You are having section A, forces, and B, friction. So in this forces, you are having these theory questions, but in friction, this is the part B. You are getting few theory questions like types of friction, basics, laws of friction, basic loss of friction, and also explain limiting friction, angle of repose, coefficient of friction, and also numericals. So angle of repose, limiting friction, angle of that's coefficient of friction. This is mu. So these are the very important thing in friction topic. Theory. My suggestion is you have the problems associated with forces are very easy, while problem associated with frictions are a little bit tough. That's why whatever my suggestion is, please concentrate on all theory questions. Nearly only 6 to 7 theory questions in entire module number 2. So please concentrate on these 7 theory questions without skipping these 7 questions. Please concentrate on all 7 questions, because the setter may mix the part A and part B, both the things. So that on that cases they may ask numerical in force and theory part in friction. Sometimes they may ask separate A section, separate B section. So here also you are getting 2 questions, 20-20, you have to answer any one question. In each question you are getting 3 minimum subdivisions, A, B, C. That's why my suggestion is don't skip these 7 theory questions in module number 2. Don't skip these 7 questions. That is parallelogram, variance, Lami's, idealizations, some theory topic, and also in types of friction, angle of repose, limiting friction. Don't skip this theory concept in module number 2. Now we discuss what are the numerical, very important numerical associated in module number 2. In numericals, first we are having numericals with respect to parallelogram law of forces. Generally, if they ask theorem, they won't ask the numerical. If they ask numerical, they won't ask the theorem, parallelogram law of forces. So that's a direct computation of resultant and its inclination. And also using rectangular component. What is the equation you have to remember? The resultant and its inclination. Type 1 numerical. Type 1 problems. Find R value. R is resultant. R equal summation of sigma fx square plus sigma fy square. Sigma fx square plus sigma fy square. And inclination, resultant inclination, that is resultant inclination, that is theta. Theta is nothing but tan theta equals magnitude of sigma fy divided by sigma fx, or theta equals tan inverse of magnitude of sigma fy by sigma fx. In this case, you are expected to direct problem, find the resultant and its inclination. Find the resultant and its inclination for 6 marks. The problem associated with this kind are generally like this: 10 kilonewton, 30 degree, 30 kilonewton, 45 kilonewton, like this. They may give direct problem. They will ask to compute resultant and its inclination. In this case, you have to resolve the inclined forces and take whatever the horizontal and vertical forces given as it is. Use proper sign convention. It is very, very important. Here, if you resolve this in pure vertical as well as pure horizontal, that is called free body diagram. Have to represent all inclined forces into pure horizontal and pure vertical forces is called free body diagram. So how to resolve this? How to resolve this? Please keep one single point in your mind. That is very, very important point. Here, if any quadrant XY, the force direction, it may be inclined towards joint or away from the joint. The possibility of inclination is with respect to x-axis or with respect to y-axis. The possibility of equation in a quadrant, that is with respect to x-axis or with respect to y-axis. Please keep in your mind, whatever the inclination, whether it may be in x-axis or it may be in y-axis, the inclination direction side angle is cos theta. For example, here I am giving theta, here P. If you resolve this, first is direction, it is inward. So both horizontal and vertical are inward. And the angle is horizontal theta. Therefore, horizontal is P cos theta, vertical is P sin theta. Similarly, apply the same thing. The force is acting away. Therefore, this is 10 cos 30 and vertical is 10 sin 30. 10 cos 30 and vertical is 10 sin 30. Similarly here, the vertical angle is given. Therefore, the vertical is cos theta, 45 cos 20. The remaining is 45 sin 20. That's all. That is the easiest way to remember how to resolve the forces in two-dimensional system. This is very, very important thing. After the resolution, apply what is sigma fx. Sigma fx is summation of all horizontal forces. For sign convention, for horizontal forces, you are applying right side acting forces are positive, left side acting forces are negative. If you observe here, it's acting with respect to origin, right side, therefore 20 plus 20, this is acting left side, therefore minus 45 sin 20, it's acting right side, therefore plus 10 cos 30. 1, 2, 3, only 3 horizontal forces. Take the sum, that is sigma fx. Similarly, take sigma fy. For this, sign convention is all upward forces are positive, downward forces are negative. Here, how many vertical forces? 1, 2, 3, 4. Out of 4 vertical forces, 1, 2, 3 forces are acting upward direction, 1 force is acting downward direction. Therefore, upward force sign convention is positive. Therefore, plus 10 sin 30 plus 30 plus 45 cos 20 minus 30. This is acting downward. That's why minus 30. So, you have to determine sigma fy by summing all vertical forces. Then, once you know sigma fx and sigma fy, then the resultant equation is given by square root of sigma x square plus sigma fy square. Our value is over. Next, substitute in this equation theta equal tan inverse of sigma fy by sigma fx. We know the value of sigma fy and sigma fx. Just substitute here, you are getting theta value. So this is the direct question. Generally, we will ask in examination. And what is another type of question expected in examination? That is also very, very important. In second type of question, the thing is little bit conditionally oriented problems. Conditions. We will impose certain conditions in the problem. What are those conditions? It's very, very important. See here, there are 2 components, sigma fx and sigma fy, and r. Here r means resultant. Sigma fx means summation of all horizontal forces. Sigma fy means summation of all vertical forces. Now, if all forces, all vertical forces acting in y or with respect to vertical axis. What it means? This statement means sigma Fy is nothing but resultant and sigma Fx equal 0. There is no horizontal forces. All vertical forces are acting in y-axis or in vertical direction. Therefore, sigma Fy equal R, sigma Fx equals 0. This is the first condition. With respect to this condition, you may expect few questions in examination. Only one question in examination for 6 marks. Similarly, the second condition is if all horizontal forces acting in x direction, which means sigma Fx equal R and sigma Fy equals 0. In sometimes what the condition they may give, like all the resultant in pure x direction, the resultant in pure y direction, which means the resultant in pure y direction. Here the resultant is pure x direction. So you have to carefully observe the problem. Statements are very important. And also in the third case, resultant is inclined. Resultant is inclined. Say for an example, this R is the resultant. I am giving theta with respect to x-axis. Then R cos theta, R sin theta. So here sigma Fx equal R cos theta and sigma Fy equals R sin theta. Maybe vice versa. If in case R, I will give theta inclination with respect to y-axis, the direction plays a role. R cos theta, R sin theta. Simple resolution. Then sigma Fx equal R sin theta and sigma Fy equal R cos theta. It's very important. So these are resultant inclined cases. On these three cases, you may expect few numericals. What are the expected numericals? Here, all forces acting in vertical direction. They may send a question like 3 forces are acting on a concurrent force system shown in figure. One of the force P is unknown, or they may give any inclined forces like P and theta. Find the unknown force and its inclination if all forces are acting vertical. So on that cases, you are getting 2 unknowns, P cos theta, P sin theta. You have to apply the condition. Then you are getting P cos theta, P sin theta value. If you take the ratio, you are getting theta value. Then by reverse distribution, you are getting P value. That is the one type of problem. Few numericals associated with these type of conditions I have already uploaded in my playlist. Once again, I will upload the same problem, relevant problem in relevant modules folders. Please go through those problems. Those problems are very important. Within this particular concept, you are expected to get one numerical. So my suggestion is, if you perfect with theory concept, if you perfect with this simple problem, you are getting 100% 20 marks in module number 2. You are getting 100% 20 marks in module number 2. So these are the 3 concepts. In some cases, very quality problems are like the transmission tower problem, 10 kilonewton, 20 kilonewton, a guide wire, a guide cable with some inclination. Determine the unknown force developed in the tension cable. This is very important. That is associated with this type of or this kind of conditions. Here also you may expect like 26 kilonewton force is the resultant of 2 forces. One of the forces is unknown and one force is given. Determine the unknown force and resultant. That is with respect to third case. So these are simple problems. You just observe the problem statements carefully and you have to solve those problems. All associated numericals are uploaded in playlist. Please go through each and every single problems. And also the second type, these are the first type. In first type you are expected to get 4 variety. Those are all simples. Using these equations you have to solve. The next one is numerical associated with Varison's theorem of moment. That is also very important. Numerical associated with Varison's theorem and Lani's theorem. Varison's theorem, that is very important. You may expect it to get this type of question. Find the position. Find the position. Like this. Like this. These are with respect to position. You are getting one more important concept along with this. B equal magnitude of sigma r by sigma m. X intercept equal sigma fy by sigma m. Y intercept is sigma fx by sigma m at particular point. These are all the equations you have to remember. Addition to solve this problem. So these are another type. There is type 2. So with respect to non-concurrent forces, and also in type 3, Lani's theorem sphere problems. Lani's theorem sphere problems. So you may get two sphere problem. Determine the contact forces. Very important. Using Lani's theorem concepts or equations of equilibrium you have to solve. Those problems are also I have uploaded. So you just follow this sphere problems is enough. And also friction, you are getting block friction problem. One or two problems, you just go through those things. So it completes your second module. Basically, in second module, what are the important rememberable things? That is, the first is theoretical concepts. In theoretical concepts, 3 derivations or theorems: parallelogram law, Varison's, Lani's, and also few theory points. This is the lengthiest module of all compared to 5 modules. Second module is very lengthy. That's why my suggestion is keep things with yourself restricted. That's why please complete all 7 theory questions, and also in numerical part, resultant and inclination associated problems, Lani's theorem problems, Varison's theorem problems. Minimum 1 or 2 problems. Those problems are already uploaded in my channel. Please go through those problems. You are getting full Pakka 20 marks in second module. So I hope in this particular session we discussed whatever with respect to module number 2 is clear. Please, if you are having any doubts, you just put in the comment section. I will clarify your doubts. Thank you for listening. With respect to module number 2, I have cleared all the things expected questions in MITU exams. Thank you.